Ridge regression showed you how an L2 penalty can shrink coefficients to tame overfitting, but it leaves every feature in the model just smaller. What if you have hundreds of inputs and you suspect only a handful actually matter? Wouldn't it be great if the model could quietly switch the useless ones off for you, all by itself? That is exactly the trick Lasso pulls. One small change to the penalty, and suddenly your regression starts selecting features while it fits. The consequence runs surprisingly deep, and it is worth seeing clearly. Let's dig in. Look, Lasso is still ordinary linear regression at heart. What changes is the objective it minimizes, so follow the construction one piece at a time. Begin with the plain squared error loss, the same one ordinary least squares uses. It measures how far your predictions sit from the true values, and minimizing it alone is what gives you the classic best fit line. That is our starting point. Now add the twist. Lasso tacks on a penalty equal to lambda times the sum of the absolute values of the weights. Notice absolute values, not squares. That single choice, an L1 penalty instead of Ridge's L2, is where all the magic hides. Then minimize the whole thing, the error plus that penalty, together. The optimizer now juggles two jobs at once: fit the data well, and keep the total size of the coefficient small. Coordinate descent handles this, since there is no neat closed form to solve for. Here is the payoff. Because the penalty grows with absolute size, weak and unhelpful coefficients get pushed all the way to exactly 0, not merely shrunk. Geometrically, the L1 constraint is a diamond with sharp corners on the axis, and the solution loves to land on a corner where some weights simply vanish. That is automatic feature selection baked right into the fit. So how does this differ from Ridge, its close cousin? Here they're laid side by side. Ridge regression shrinks every coefficient toward 0 using an L2 penalty, but it never quite reaches 0. Every feature stays in the model, just with reduced influence. That stabilizes correlated predictors beautifully, yet does nothing to simplify the model or tell you which inputs actually earn their place. Lasso, by contrast, drives the useless coefficients exactly to 0 and drops them entirely. What you get back is a sparse model that uses only the most informative inputs, so it both regularizes and selects features in one move. Larger lambda means fewer survivors, and the ones left are the ones that truly matter. Strip it all down, and 3 ideas define what Lasso really is. It is built on an L1 penalty, the sum of the absolute values of the coefficients. That absolute value, rather than square, is the whole reason Lasso behaves so differently from Ridge. It drives weak coefficients exactly to 0, rather than gently shrinking everything. The L1 corner geometry switches unhelpful features off completely, so the penalty strength lambda directly controls how many features survive the fit. It hands you a sparse, self-selecting model. Only the informative inputs remain, which makes the result both regularized and genuinely interpretable. The catch is that among a group of correlated features, Lasso tends to keep one arbitrarily and 0 the rest, and it can wobble when features outnumber samples, which is exactly why elastic net blends in a little L2. All right, let's lock in what matters. Lasso regression is linear regression with an L1 penalty, the least absolute shrinkage and selection operator, added to the usual squared error loss. Because it penalizes the absolute size of the weights, it pushes weak coefficients exactly to 0, performing automatic feature selection while it trains. The penalty strength lambda, tuned by cross-validation, decides how sparse the model becomes. Larger values keep fewer, more informative feature to life. Its quirks, arbitrary picks among correlated features, and instability in very wide data are precisely what ElasticNet was invented to fix. If untangling machine learning this way clicks for you, a whole library of these explainers is waiting for you over at standardy.com. Come explore.